Hello, welcome students. Welcome to the new session. Today, myself Sham Gore from DSM College Intur, we are going to discuss about the proportional voltage formula. Before proportional voltage formula, let us see what is the parallel and series circuit. This is the series circuit. Here, the components are connected one after other. That circuit is known as the series circuit. Okay. In series circuit, total voltage across component is total voltage across the circuit is sum of voltage across the each component, and the current flowing through the each component is same. Here in the series circuit, the current flowing through the each component is same, but the voltage across the component is different and such types of the circuit is known as the series circuit. Okay, and this is the parallel circuit. If you are looking towards this circuit, the components are connected, one component is connected in front of the another, and such circuit is known as the parallel circuit. And in parallel circuit, the voltage across each component, that is R1, R2 and Rn, the voltage across each component is same, and the total current flowing through this circuit is the sum of current flowing through each component, that is known as the parallel circuit. Okay. So, the series circuit is like this. Here, this is the series circuit and it has only one line, and in between this line there may be the number of resistances. Okay. Such types of the circuit is known as the series circuit, and a series circuit in which the current can flow through only one path, because here there is only one path, and therefore the any current which is flowing through the circuit is the same, because it can be flow through only one path, and this is the current I. The current is same at all points in the circuit. If you see the current at this point, at this point, or at this point, the current is same in series circuit and the total resistance is equal to this resistance plus this resistance, like this. The total resistance is equal to the sum of the all resistances in the series circuit, that is the R total is equal to R1 plus R2 plus R3 and the voltage is equal to the V1 plus V2 plus V3. This is the series circuit. Now let us see the parallel circuit, and the parallel circuit is like this. If you are looking towards the parallel circuit, it has the number of branches. This is the first branch, this is second branch, this is third branch. In this way, here in the circuit there are the three branches, and such types of the circuit is known as the parallel circuit. And in parallel circuit there are multiple paths, number of paths are available in the parallel circuit, and the different path may contains the different flow of current, that is depends upon the resistance of the branch, and this is based on the Ohm's law. And the total resistance of the circuit, here if you are taking the total resistance of the circuit, then the total resistance is the less than the smallest resistance of the resistor, and here the total resistance is equal to 1 divided by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the parallel circuit. Okay, and the total current is equal to I1 plus I2 plus I3, means the current flowing through this plus this is the total current. So these are the parallel circuits. Now let us see the proportional voltage formula. Okay, here this is one circuit. Here the three components are connected, R1, R2 and R3, and all these components are connected in series. Okay, so let us find out the proportional voltage formula. Here the voltage across this component and this component can be obtained. So in series circuit, voltage drop varies directly to the resistance. Here the voltage is depends upon the value of resistance. Hence, the simple relation can be found to calculate the individual voltage drop without finding the current flowing through this circuit. If you want to find out the voltage across this resistance or this resistance or this resistance, you can find out the voltage across the any individual resistance without knowing the current, how much current flowing through this circuit. And so let us see the voltage across the any one of the component, and we know that the voltage across any resistance is equal to the current flowing through that resistance and into voltage across that resistance, that is the current into voltage is equal to resistance. Okay, voltage across any resistance is equal to current into resistance, not voltage. Okay, voltage is equal to current into resistance. Here there is the resistance, and V is equal to IR. If you want to find out the voltage across this resistance, suppose the voltage across this resistance is equal to V1, and that V1 is equal to the current flowing through the circuit is I. The total current or the current flowing through the circuit is I, because the same current is flowing through the all components. Therefore, I is the current flowing through the resistance R1. Therefore, V1 is equal to I into R1. But we know that I is equal to V divided by R. Okay, and here V is the voltage, that is the total voltage of the circuit, and R is the total resistance of the circuit. Okay, then V1 is equal to, if you look in towards this V1 is equal to I into R1, and therefore V1 is equal to, let us substitute the value of I is equal to V divided by R. Therefore, this I is equal to V divided by R. Therefore, V1 is equal to V into R1 divided by R. This is the proportional voltage formula for any voltage, any branch voltage, that is the proportional voltage formula. In this figure, this is the figure in which the battery is connected, and that is, this battery is the 24-volt battery. Okay, and in this the three resistances are connected, R1, R2 and R3. Now the total resistance is equal to R1 plus R2 plus R3. Here R is equal to, R is the total resistance, that is equal to R1 plus R2 plus R3, the sum of all resistances. And here R1 is the 2 kilo ohm, R2 is the 4 kilo ohm, R3 is the 6 kilo ohm. Therefore, 2 plus 4 plus 6 is equal to 12 kilo ohm. Now this is the total resistance of this circuit, and according to the proportional voltage formula, various voltage drop across any resistance. Now let us find out the voltage across this resistance, that is the V1. V1 is equal to V into R1 divided by R, and that is equal to 24 divided by 2 divided by 24 into 2 divided by 12, which is equal to 4 volt. Means the voltage drop across this resistance, that is the V1, is equal to 4 volt. And according to the proportional voltage formula, voltage across any resistance is equal to the total voltage into the individual resistance divided by total resistance. This is the proportional voltage formula, that is the voltage across this resistance. Now let us find out the voltage across the resistance R2. Suppose the voltage across this R2 is equal to V2, and that V2 is equal to V into R2 divided by R, and that is equal to 24 into 4 divided by 12, and that is equal to 8 volt. This is the proportional voltage formula. According to the proportional voltage formula, the voltage across the any resistance, that is the R2, is equal to, suppose voltage across R2 is equal to V2, and according to the proportional voltage formula, the voltage across any resistance is equal to the total voltage into its individual resistance divided by total resistance. Therefore, the V is the total voltage, that is equal to the 24 volt into R2. Value of R2 is equal to 4 ohm, and the R is the total resistance, that is equal to 12, and therefore that is equal to 8 volt. So the voltage across this resistance is equal to 8 volt. Similarly, let us find out the voltage across this resistance R3, that is the 6 kilo ohm resistance, and that V3 is equal to V into R3 divided by R, which is equal to 24 into 6 divided by 12, and that is equal to 12 volt. So in this way we can find out the voltage across any individual resistances, and such formula is known as the proportional voltage formula. And what is the proportional voltage formula? Proportional voltage formula is the voltage across any resistance is equal to the total voltage into its individual resistance divided by total voltage. So this is the proportional voltage formula. And let us see the series divider, that is the series voltage divider. A simple voltage divider which consists of the two or more resistances connected in series across a voltage source, say the voltage divider. And the voltage divider is like this: when we connect the two or more resistances across the voltage source, then the each resistance can be works as the voltage divider, like this. This is the voltage divider circuit, and here this is one resistance, this is the second resistance, and here the voltage or the battery which is connected between the two resistances is equal to 100 volt. Therefore, here the each resistance divide the voltage, that is depends upon value of that resistance. So the current flowing through the each resistance is the same, because this is the series circuit, and the current flowing through the resistance which gives the value of voltage. Okay, the voltage can be used for, such circuit is used for the load need voltage less than the battery voltage. Such voltage divider circuit are used when it is necessary to obtain the different value of the energy sources. If we want the voltage other than the 100 volt, then we can divide this voltage into the resistances. Okay, now let us find out the voltage across this resistance, that is the R1. Voltage drop across the resistance R1 is equal to, according to the voltage divider rule, the total voltage, that is equal to the 100 volt into its individual resistance, that is the 150 ohm, okay, divided by total resistance is equal to 200 ohm, that is the 150 plus 50 is equal to 200 ohm, and that is equal to the 75 volt. Therefore, the voltage drop across this resistance is equal to 75 volt. Out of 100 volt, 75 volt is drop across this resistance. Okay, and let us find out the voltage drop across another resistance that is equal to R2. R2 is equal to 100 into 50 divided by 20, that is equal to the 25. Out of 100 volt, 75 voltage drop across this resistance and 25 volt drop across this resistance. In this way, this is the series voltage divider, and when the such types of the resistances are connected in series, then they can divide the voltage, and such circuit is known as the voltage divider circuit. And here at a point A, voltage is equal to 100 volt. At a point B, voltage is equal to 25 volt. And at a point C, the voltage is equal to 0 volt. Okay. So, these are the values of voltages. Here we have 100 volt, and that 100 volt is divided like this. Here we have 100 volt, here we have 75 volt, and sorry, here we have the 75 volt, here we have 25 volt, here we have 0 volt. Similarly, here the transistor is also used, and in this transistor one power supply is connected, that is the VCC, which have 9 volt, and here the voltage at the collector is equal to the 9 volt, but the base required another voltage or different voltage. Okay, base required some less voltage than the 9 volt, and for that purpose we are using such types of the resistances. We are connected the two resistances R1 and R2, and here these two resistances works as a voltage divider. And here a simple series voltage divider network, that is R1 and R2, is used, and these two resistances divide the voltage of the source voltage. And here the total voltage across R1 minus R2, here the total voltage from R1 to R2 is equal to 9 volt. From here to here, the voltage is equal to the 9 volt, and the voltage drop across this resistance R2 is equal to the total voltage into its individual resistance divided by total resistance, that is the 9 into 3 divided by 9, which is equal to 3 volt. Therefore, the voltage for the base is equal to 3 volt. In this way, by connecting these two resistances, we can divide the voltage, and here at the base of the transistor, the voltage is equal to 3 volt. In this way, this is the series voltage divider by using the two or more transistors, sorry, resistance in series. Okay, thank you for watching this video.